Hello everyone, welcome to third video, and today we will talk about arithmetic operations of matrices in Matlab. In Matlab, actually there is two types of arithmetic operations. One of them is scalar and one of them matrix operations. The scalar operations are similar our daily operations like addition, multiplication, division, exponentiation, something like that. But matrix multiplication, division and exponentiation are a little bit different. First of all, let's start with addition, subtraction, multiplication and division. The addition is similar with scalar addition. When you try to add two matrices, you need to add the same element of two matrices. For example, let's say we have A and B matrices, which they are 2 by 2 matrices, and if you want to add these matrices, you need to add same elements of that matrices. For example, in here, the first element of A and first element of B, which is 4 and 1, we need to add them and we need to write it the first element of the result matrices, and we need to add we need to do the same thing at the second element, third element, the second row, first column, second row and second column. We need to do that for all elements in the matrices. At the same way, we can do subtraction, we can do multiplication, and we can do division processes. But there is another operation in Matlab, also in matrices, which is matrix multiplication. Matrix multiplication is a little bit different than scalar multiplication because it has both scalar addition and scalar multiplication. And to multiply two matrices, we have some restrictions. The restrictions is the column count of the first operator should be the same the row count of the second matrix. I'm saying again, the column count of the first matrix should be same the row count of the second matrix, and the result matrix and the row count of the result matrix will be the row count of the first matrix, and the column count of the second matrix will be the column count of the result matrix will be second column count of the second matrix. In here, if you multiply m by n matrices and n by p matrices, the result will be m by p matrix. As you see here, the column count of first matrix and the row count of the second matrix should be same. In here, they are n, they both n. And how will we do that multiplication? Let's say we will multiply 2 by 2 matrices, and let's say A1, B1, C1, D1 are the elements of first matrix, and the A2, B2, C2 and D2 are the elements of second matrices. And in that example, our result matrices will be 2 by 2. Why? Because the row count of the first matrix is 2 and the column count of the second matrix is 2. So our result matrix will be 2 by 2. And for the first element, we need to multiply first row of the first matrix and first column of the second matrix. We need to multiply rows of first matrices and the columns of the second matrices. In here, if we multiply the first row of the first matrix and the first column of the second matrix, our result will be A1 times A2 plus B1 times C2, as you can see here. The first row and first column of the result matrix, you can see that. If you find this element, which is first row and second column of the result matrix, you need to multiply first row of the first matrix and the second column of the second matrix. As you can see here, A1 times B2 plus B1 times D2. And if you want to find the second row and first column of the result matrix, right now we need to multiply the second row of the first matrix and the first column of the second matrix, which is C1 times A2 plus D1 times C2, as you can see here. At the same way, the last element will be C1 times B2, D1 times D2, and we can add that. We can add them. And matrix division is a little bit complex, so we don't cover that in that video. Okay, let's try in Matlab. Let's delete that. Okay, let's clear here. Yes. Let's create two matrices. M1 equals 1, 2, semicolon, 3, 4, which is 2 by 2 matrices. Let's define another matrices, which is, let's say 1, 2, not 1, 2, 5, 6, 7, and 8. Oops, I wrote colon instead of semicolon, and we can change in here. Yes, now I have two 2 by 2 matrices, and right now I can add them. M1 plus M2. The result will be the addition of these two matrices, and first row and first column of second matrices was 5, and first row of the first column of the first matrices was 1, and when you add them, the result will be 6, and 6 plus 2, the result will be 8. 7 plus 3, the result will be 10. And the last element, 8 plus 4, the result will be 12. At the same way, we can use the subtraction M2 minus M1. when you write it, you will see the differences between M2 difference values and between M2 and M1. M2 minus M1. In here, 8 minus 4 is equal to 4. 6 minus 2 is equal to 4. 7 minus 3 is equal to 4. And finally, 5 minus 1 is equal to 4. And if you create another matrix, which is, let's say, 4, 5, 6, 7, 8, 9. Now we have a 2 by 3 matrix. If you try to add M1 and M3, Matlab will throw an error. Why? Because if you want to add two matrices, their size should be same. As you can see here, the error says arrays have incompatible size for this operation because they need to be same, like M1 and M2. And for the scalar multiplication for two matrices, we can use M1 dot star asterisk M2. For scalar multiplication, we need to use dot before the multiplication operator, and that means the multiplication will be scalar, not matrix. If you write M1 times M2, the result will be different. The result will be the matrix multiplication. But in here, the result will be the scalar multiplication. How? Let's write M1, M2, and M1 dot asterisk and M2. Yes. 1 times 5 is equal to 5. 2 times 6 is equal to 12. 3 times 7 is equal to 21. 4 times 8 is equal to 32. And at the same way, we can do a scalar division. Let's say M2 dot slash M1. And here we use dot, and that means that the operation will be scalar, and here is M2 and here is M1. 5/1 will be 5, and 8/4 will be 2. And here, as you can see, we used slash. That means M2 over MT. But if you use M2 dot backslash M1, that means right now M1 over M2. And let's look M1 and M2. Right now M1 is the upside of the division, and 2 over 6 will be 0.3333, and 4 over 8 will be 0.5, and 3 over 7 will be 0.426 8 and 6. And let's look at the matrix multiplication. So we have M1 and M2 and their sizes are 2 by 2, so we can multiply them. M1 asterisk M1 times M2. Right now we have multiplied them, and as you can see right now, for the first element of result we need to multiply the first row of the first matrix and first column of the second matrix, which is first row is 1 2, the first column is 5 7. 1 times 5 equals 5, 2 times 7 equals 14, and 14 plus 5 will be 19. And the same way, for the first row and second column of the result matrix, we need to multiply first row of first matrix and second column of the second matrix, which is 1 times 6 will be 6, 2 times 8 will be 16, and the 16 plus 6 will be 22. And let's remember M3. M3 was 2 by 3 matrix. Let's try to multiply M3 and M1. As you can see, it will throw an error. Why? Because the column count of the first matrix is not same with the row count of the second matrix. This is the rule for matrix multiplication. And let's look. Size M3, the size is 2 by 3, and the size for M2, the size is 2 by 2. So the column count of the first matrix is 3 and the row count of the second matrix is 2. They are not same. This is the reason of that error. And so we can multiply M2 with M3, but this time the order is different. Why? Because the column count of M2 is same with the row count of M3, and as you see, the result has the same row count of the first matrix and same column count with the second matrix. And for let's look at the exponentiation of a matrix. Let's get M1 again, which is 1 2 3 4, and if we use M1 that and hat 2, which means a square of M1, right now we can see that a square of M1, which is a scalar square. Why? Because we are doing a scalar exponentiation process in here. The square of 1, the square of 2, the square of 3, and the square of the 4. What if we use matrix exponentiation? Let's use it. M1 hat 2. And right now we have a different answer, different result. Why? Because this is a matrix multiplication. Sorry, this is a matrix exponentiation, and matrix exponentiation use matrix multiplication. For example, m1 times m1. As you can see, the results are same. Why? Because the m1 square means m1 multiply m1. So if you use m1, if you try to exponentiate m1 over 2, that means m1 times m1, and we can use m1 hat 3. That will means m1 times m1 times and m1. The results will be same because they are same things. This is a matrix exponentiation, which means multiply the m1 3 times. Let's try it for m3. m3, let's remember m3. m3 was a 2 by 3 matrix, and let's m3 hat 2. This time it will throw an error. Why? It will do a matrix multiplication, and to do a matrix multiplication we had a rule. What was the rule? The rule was the column count of the first matrix should be same the row count of the second matrix. Right now we use m3 as a first matrix and m3 as a second matrix, and the column count of m3 is 3, but the row count of m3 is 2, and they are different. This is the why of that error. We can't multiply these dimensions. Like in exponentiation processes, like here, we can use scalar values for addition, multiplication, division, subtraction. How? Let's remember m1 again, and let's add m1 and 5. Now result is addition of 5 and m1. Matlab will add to each element of m1 5. 1 plus 5 6, 2 plus 5 7, 3 plus 5 8, and 4 plus 5 is 9. And we can do the same thing for the subtraction. m1 minus 1 will be 0 1 2 3. m1 multiply 4 will be 4 8 12 and 16, because we multiplied of each element with 4. And at this time you don't need to use dots, as you can see, because the right side of the operator is scalar. That means the operation will be scalar. But if you try to multiply two matrices, you need to write dot for the scalar multiplication or scalar operations. And for the arithmetic operations, there's some precedence. Right here. When you write multiple operations, when you use multiple operators at the same line, at the same command, Matlab execute them in an order. How? Like in Matlab has a precedence of operators. First, the parentheses. Second, exponentiation and transpose operators. And then unary signs, which is the positive and negative signs, and logical negotiation. We didn't see that. And after that, we have multiplication and division. These are before the addition and subtraction, like in math. And at the end of these operators, we have a colon operator. Let's look at that in Matlab. Let's create matrices again. 1, 2, 3, and 4. And let's clear the window. Right now I don't use that matrix, but I will use it later. We have colon operators. As you remember, we had, let's say, 1, 2, and 5. That means it will start from 1 and step size will be 2 and its endpoint will be 5. Let's write it. Now we have a row vector, as you can see that. Let's say A equal 1, 2, and 5. Right now, as you can see in the workspace, A is 1 by 3 a row matrix, which is a row vector. What if I use 1, 2, 5, but this time a transpose? What will be the result? The result doesn't change. Why? Because Matlab used the precedence table. In this command, the priority is in transpose operator. Why? Because in the table transpose has higher priority than colon operator. So Matlab executes the transposition before the colon operation. So how can we transform this to a column vector? Let's look at the table. We need to use colon operator before the transpose. So we need to use higher priority than transpose, and which is a parenthesis. And right now, if I use B equals 1, 2, and 5, and after the parentheses, the code, right now Matlab will execute first the inside of the parentheses, and then it will execute the transposition, and it will return 3 by 1 a column vector. The same way, if you write 5 minus 3 plus 1, right now Matlab look at the table and MATLAB will see the subtraction and addition are at the same level. And right now at the same level of the precedence, MATLAB always executes from left to right. In here it will execute the subtraction first and it will execute the addition later. Let's write 5/2 multiply 2. Now MATLAB will look at the table and it will see that the division and multiplication are in the same level of the table, and MATLAB execute from left to right. Now it will make the division and the result will be 2.5, and then MATLAB will that multiplication, the result will be 5. If MATLAB used here first, the result will be different, but MATLAB always executes from left to right for the same level precedence operators. And if you write here 5 plus 4/2, right now MATLAB will look the precedence table and it will see that the division operator has higher priority than addition operator. So it will do the division first and addition later. So the result will be 4/2 will be 2 and 5 plus 2 will be 7. Oops. Yes, the result will be 7. And this is the end of our video, and see you in the next video. Bye.